couple definitions that we do need to take a look at here today are dealing with vectors. Today we're going to take a look at translations and vectors and how vectors work. And with translations, a translation is simply going to be a slide of a figure. Vectors are one way that translations or figures can be slid using a translation. A vector is a quantity that has both direction and magnitude or size, and it's represented by an arrow drawn between 2 points. Now that vector is a constant motion from one point to the next, and we're going to talk about those later on in the school year as well, again when we get back into our trigonometry unit later on. The initial point or starting point of the vector is P, and our terminal point or ending point is going to be Q. Vectors have beginning points and terminal points, and even though they have terminal points, they are still a motion from one point to the next. And the component form of a vector combines its horizontal and vertical components, and you can use that in order to find the magnitude. Okay, at this point we can go ahead and pause the presentation so the students do have opportunity to go ahead and finish off copying down these definitions. Okay, vector notation has the less than and greater than symbols around 2 points in an ordered pair form. Okay, the magnitude is the length of the vector, and it's going to be given by the formula, the square root of a squared plus b squared. Now that magnitude is still going to be the distance formula could be used as well for that. When you look at a and b, it is the movement from one figure to the next. So when we talk about vector 4, 3, that is how it looks in vector notation. Okay, where you've got the 4 as the x component, or how far you're moving in the horizontal direction, and 3 in a component form for the y, which is telling you how far you're moving up and down. Now, in order to find out your value of your vectors, one thing that you can do is find the length of the vector. Okay, and in order to find that length, what we're going to do is first of all find our component form. Okay, I'm going to start at 0 and I'm going to end up at 5, which means I'm moving from 0 to 5. So what we want to think about is how many units we're moving to get from 0 to 5. Okay, if I start at 0 and go to 5, I'm moving 5 units in the right direction. And when our vector is a positive number in the first number, then it's going to be moving to the right. If the first number is negative, your vector is moving to the left. Okay, since I'm going from 0 to 5, my first number has a positive component of 5. Now for my y component, if I move up, my vector is positive, and if I move down, my y component is going to be negative. Okay, so I go from 0 to 3, okay, which means I'm moving up 3 units. So my vector component form for the y is 3. So 5, 3 is what my vector is written as in component form. Now, what we're going to do with that then is we're going to go ahead and take and find the magnitude of our vector by taking a squared plus b squared. Well, we've already found the distance between those 2 points. So if you can't remember the vector form, you can always find a distance between the points. And that distance is going to still be the length of our vector. Okay, but using component form will help also. So I'm going to take 5 squared plus 3 squared. Okay, it's going to be a little less work this way. And 5 times 5 is 25. 3 times 3 is 9. And 25 plus 9 gives me the square root of 34. And that is the length of our vector, or magnitude of the vector. Okay, length and magnitude are the exact same thing. Now, the next one that we see to the right, we have the points 2, 1 and the point 5, 3. If I start at 2 and move to 5, how many units am I moving? That is the question we're trying to ask. Okay, and that's going to go from 2 to positive 5 is obviously going 3 units to the right, which means my x component is going to be 3. Okay, then y component is going to be moving between 1 and 3. Okay, and since my y component starts at 1 and moves to 3, it's going 2 units, and those 2 units are moving up. So my vector component is 3, 2. Now, what we're going to do to find the magnitude is we're going to simply take and square both those numbers, add them together, and find a square root. So 3 squared plus 2 squared gives me 9 plus 4, which is the square root of 13. And that's our vector form and the length of those 2 vectors. Any questions on that? Okay, again, you can use the distance formula if you want to find the magnitude of the vector to work just as well. Okay, we're going to take a look also at mapping using a coordinate mapping. And we want to describe a translation that maps the solid figure onto the dashed image using word and coordinate notation. what we're going to do is we're going to pick 2 points. Okay, I'm going to take the bottom left point in both of these squares. Okay, it's a little bit tough to see, I'm sure, especially if we got a sunny day outside as you're looking at this. But I'm looking at the bottom left vector, or bottom left point. I'm moving this far in my x direction, this far in my y direction. Now, what that's going to give me is my component form of the vector. If I count my x direction, how far I'm going, moving 1, 2, 3, 4, 5, 6 units to the right. So my vector's x component is positive 6, and I'm moving 2 units up, so my y component is positive 2. Okay. Now, what we also want to do is something called a coordinate mapping as well. And some of you have seen that coordinate mapping. What we're going to do is we're going to take the points x, y, and we're going to move that to a new point. Okay, and all that is it's going to be using coordinate notation instead of the vector coordinates to find our point. So since I'm moving to the right, my x is going to add 6 units to it, and since I'm moving up, I'm going to have it be y plus 2. This mapping allows me to use coordinates in order to find and plug in points to find those values. And you've seen me as we've gone through with this reflections, have x, y going to something, or like when we did the rotations the other day, we did x, y going to y negative x. Okay, that is a coordinate mapping for those points. Okay, again, x is positive if it goes to the right, x is negative if it goes to the left, y is positive if it moves up, y is negative if it moves down. Okay, again, we're going to describe the translation. It maps the solid figure onto the dashed image using words and coordinate notation. Okay, now this time we're not using the vector form like we had to the last time. Okay, actually in the last one we should also take a look at that in vector form, and I should mention that we do need to move it right 6 and up 2. Okay, in this problem that we've got here, again, we want to take points. Okay, we're going to use those 2 points, the top left part of my triangle, and figure out which way we're going to move our points. Okay, there is our movement in our vectors. Okay, we know we're moving left a certain number of units and up a certain number of units. Okay, so now we need to count our blocks to figure out how far we are moving to the left. When we count the blocks, we're 1, 2, 3, 4, 5. So we're moving left 5 and up 1, 2, 3, 4. So that is our description of our vector using words. Now for coordinate notation, we're going to again put the points x, y into a coordinate mapping. Now, since we're moving to the left, we're going to take our new coordinate of x and we're going to do what with it? Since it's moving left, we have to subtract the number of units, which in this case is 5. And then our y piece is going to move up 4, so that should be plus 4. In vector notation, this would simply be the point 5 or negative 5, positive 4. Okay, if we were chose to do it using vector notation. Questions so far? Okay, we want to describe our translation using coordinate notation and a vector and component form. And here are 2 points. We're again going to go from the solid figure to the dotted figure. So this time we're going to move this way and this way. Okay, so we know we're moving left 4 units. We know we're moving down 3. So now we're going to use that in order to write a coordinate notation. Again, you always want to write the ordered pair x, y. And then we need to figure out which direction we're going to move from that. So x, y is going to go x, and since we're moving left, it's going to be minus those 4 units. And since we're moving down, it's going to be y minus 3. Using vector notation, again, the only difference now with vector notation is the outside symbols. And then instead of having the x and y in with that coordinate piece, you're just going to have the negative 4 and negative 3. Okay, we want to name our vector and write its component form. When we name vectors, we always want to start with our initial point first. And since A is the point that our vector starts at, A has to be first, and B is our terminal point up here. It's where the arrow is. And when you draw the vector, you put the the bar over top, just like we do for a segment ray or line. And it's actually very similar to the way we name array, except instead of putting an arrow on, you only put half the arrow, and it's the top half. So this is ray AB, or vector AB. Now we want to write the component form of our vector, which tells us we're moving right 3 units and up 3 units. Okay, so right 3 means we're going to have an x component of positive 3, and since it's moving up 3, we're going to have a y component of positive 3 as well. So the vector is 3, 3. Now, what this does for us, this allows us to move our figures, whether we even have a picture of our figure or not. Okay, the example we have here, we want to consider our translation xy goes to x plus 4 and y minus 1. Now what we're looking at here, the first part is to find the image. And remember, the image is the final piece that you look at. Like when you look in a reflection in a mirror, you see an image of yourself. You don't actually see yourself. Yourself is the pre-image. So that's the idea again. We want to find where we're going to go to if we start with the point 2, 5 and use the coordinate mapping of x plus 4 and y minus 1. Okay, so if I take 2 and plug it in, that's going to give me 2 plus 4. And that's going to give me a point of 6. And then we're going to take 5 minus 1, and that's going to give me 4, and that's my new point, 6, 4. For part B, we want to find the pre-image. And the pre-image is what we're going to start with if we end up at negative 1, 3. If you've ever seen Jeopardy, you found something very similar to this. In Jeopardy, they give you the answers. They want you to find the question. That's why they always start with what is. Okay, they're giving you the answer. You got to figure out what the question was. And that's what we've got here. In other words, what we've done is we've taken x and added 4 to it and ended up with negative 1. The same thing's true when we take y minus 1. We end up with 3. And what we want to do now is we want to work backwards in order to figure out what those points are. So we're going to simply solve our equation. So we subtract 4 from both sides. And that tells us our x coordinate on our pre-image is negative 5. Now we're going to do the same thing with our y. And when we add 1 to both sides there, we found out that y is 4. Okay, which tells us that our pre-image is the point negative 5, positive 4. Okay, now we want to find the image of our points using these translations. And our mapping is xy goes to x minus 3 and y plus 2. So what we want to do is we're using the point 3, 1. So we're going to take 3 and plug that into our mapping for x. So that's 3 minus 3, which is 0. And 1 plus 2 is going to give me 3. So my image of my point is the point 0, 3. The same thing's true with 0, negative 2. So I plug that in. 0 minus 3 is negative 3. And negative 2 plus 2 is 0. And that's my image. In our diagram, ABCD is going to map onto A prime, B prime, C prime, D prime by a translation. We want to write the component form of the vector that can be used to describe a translation. What we have to do is pick one point, and it does not matter which of the 4 points you use, because when you translate a figure, all 4 points should have the same side. Okay, so we're taking a look at the single point, and we're going to choose any point we want. I'm going to go ahead and take a look at A, because A has the point 1, 0. Okay, we want to take a look at that movement from A to A prime. Now, from A to A prime is at negative 3, negative 3, which means I'm going to move to the left 40 units. I'm moving down 3 units, because that's going to get me from 1 to negative 3 in the x, and from 0 to negative 3 in the y. Okay, so the vector down, what movement we've used, and I'm going to write the component form of our vector. And so we move left 4 and down 3. My vector component is -4 and -3 in the down direction. Okay, questions on that? Now, as far as the translations go, in the actual translation of a figure, translations are simply slides. So what we have to figure out is which direction we're going to move our points. Okay, and again, like we did earlier in the week, I'm going to go ahead and plot my points here in red on my pre-image. And you can either use the coordinates and count your blocks, or you can actually use the coordinates and create your new coordinates if you choose. Either way is going to be perfectly fine. Okay, if we have the vector 5, 2, that's telling us we're moving our vector to the right, or our triangle to the right 5. We're moving it up 2. So what we're going to do is we're going to do those same exact things with A, B, and C. So A is 1, 2, 3, 4, 5 units to the right and up 2. So that is going to be A prime. B, we're going to count 1, 2, 3, 4, 5 units to the right and up 2. So that's going to be B prime. And C is 1, 2, 3, 4, 5 units to the right and up 2. So that's C prime. And that is our triangle that is translated. So it's A prime, B prime, C prime. Our next one is going to be a parallelogram. And we're going to move our parallelogram A, B, C, D. And we have the coordinate mapping of x plus 3 and y minus 4, which means we're moving which direction? Okay, we're moving right 3. And since we have y minus 4, we're moving down 4. And again, we're going to count each of those blocks off. Okay, going right 3, 1, 2, 3, down 4, 1, 2, 3, 4. Okay, it's going to be B prime. C, 1, 2, 3, and down 4, 3, 4. Okay, it's going to be C prime. A, 1, 2, 3 to the right, 1, 2, 3, 4 down is A prime. And we're going to do the same thing with D. So 1, 2, 3, 4, 1, I'm sorry, 1, 2, 3, and then down 4, 1, 2, 3, 4. And that's D prime. And again, we're going to connect our dots then to create a new triangle that's been translated. Now, in some of the homework tonight, again, you might see some problems where we don't have to actually fill in the points, okay? Or you might have to just go ahead and find your coordinates, not actually have to do the graph. Okay, the vertices of triangle ABC are A, which is at -5, 3, B, which is at 4, 2, and C, which is -1, -1. We want to name a vector that describes a translation so that we get the following points down here, A prime, B prime, C prime. Again, when you're trying to find that vector to determine those points, you don't have to actually do all 3 pieces. You just have to pick one. So we're going to start with the first one. We're going to go with A. My x-coordinate for A is -5. My x-coordinate for A prime is -2. If I start at -5 and I move to -2, which direction am I moving? Okay, moving right, and I'm moving 3 units. So my x-component of my vector is +3. And my y-coordinate starts at 3 and ends at -1, which means we're moving which way? Okay, down. So we're moving down, which means my y-component is negative, and 3 minus to -1 is going to give me 4. So my vector that maps that translation is the point 3, -4. Okay, at this point in time, the sub will go ahead and pass out the homework for tonight, which is the section 7.4 worksheet, and you have the rest of the period to work on that.